this is section 6.2, number 11, a trig substitution problem. So let's see how this one goes. Here we have a constant minus x squared raised to some power. Whenever we have something like that, we have kind of the three choices. Am I going to let x equal a sine theta? Am I going to let x equal a tangent theta? Or am I going to let x equal a secant theta? If it was a squared plus x squared, we'd use tangent theta, and if it was x squared minus a squared, we'd use secant theta. But whenever we have something that looks like an a squared minus x squared, either under square root or in some term, then we're going to use this substitution. The thing that's being squared is a 7. So the trig substitution we're going to use is x equals 7 sine theta. And remember, we're hoping to do this so that this integral becomes a lot easier to do. Okay, in order to do the trig substitution, we've got to figure out what dx is. Well, the derivative of 7 sine theta is 7 cosine theta d theta. So dx is 7 cosine theta d theta. So now we're going to rewrite everything in this integral, replacing all the x's with what their replacement should be. So let's see. This would be equal to, instead of x to the 12th, I'm going to have 7 sine theta to the 12th. And instead of 49 minus x squared, I'm going to have 49 minus 7 sine theta squared. And that whole thing is raised to the 15 over 2. And then I also have this dx. I can't forget about this dx. My dx is equal to 7 cosine theta d theta. Now, it's probably not wise in this problem to try to figure out what 7 to the 12th is or anything like that. We should probably just figure out what the power of 7 is. So here I've got 12 sevens here and another 7 here. So I've got 7 to the 13th power. I've got 12 sines, so I've got sine to the 12th power, and I've got cosine theta, and I still have a d theta. Okay, so 12 of those sines, sine theta, and 1 cosine theta. On the denominator, I have something to the 15 over 2. Let's figure out what that something is. It's 49 minus 49 sine squared theta. Now, you might be at the point where you can do this in your head. If you can't, that's totally okay. What I'm going to do is I'm going to rewrite that denominator, doing a little bit of algebra and trigonometry simplifying. So first of all, I can take out that 49. If I take out that 49, it's still inside this power to the 15 halves. Everything's still raised to the 15 halves there. What else do I have? The rest, what I'll have left is 1 minus sine squared theta. Now, as you know, the whole reason we're doing this trig substitution, the whole reason we make these substitutions up here is to turn this thing, which has a minus sign in it, into something that doesn't have a minus sign in it. 1 minus sine squared theta, that's the same as cosine squared theta. So I can make that substitution. And now lots of stuff kind of turns into something nice. So I still have this 7 to the 13th sine to the 12th theta cosine theta up here. Let's see, I've got 14 to the 15 over 2. Well, 49 to the 15 over 2. 49 to the 1/2 power would be 7, because the square root of 49 is 7, and then I'm going to raise that to the 15th power. So that's the same as 7 to the 15. You can see lots of nice stuff's going to cancel out with those 7s. Cosine squared theta to the 1/2 power would just be cosine theta. And then what do I have left? Well, I've got this cosine theta to the 15th power. Okay, now it might not look like it, but our hope is that this simplifies now. So let's start seeing some stuff that can simplify. first of all, one of these cosine thetas can cancel out with one of these, and I just have 14 cosine thetas. Another thing that can happen is I've got 13 sevens up here, and I've got 15 sevens down here, so that's really the same as 2 sevens in the denominator. So when I rewrite this, let's see what I get. Well, I have 2 sevens on the denominator, so that's 1 over 49, 1 over 7 squared. I can combine 12 of these sine thetas with 12 of these cosine thetas, and I have tangent to the 12th theta. That's 12 of the sines and 12 of the cosines. And what am I left with? I still have 2 cosines in the denominator. So 1 over cosine squared theta d theta. Well, you might see it right away, but if you don't, that's okay. This one's going to work out nicely because I have 1 over 49, the integral of tangent to the 12th theta, and this is just the same as secant squared theta d theta. And this lends itself to a very nice u substitution. If u is tangent theta, then du is secant squared theta d theta. And this is just 1 over 49 u to the 12th du. This is exactly the du we want for this u substitution. This integral is not too bad to do. 1 over 49, 1 over 13 u to the 13 plus c. And the last thing I need to do is I need to plug back in and get these not only just in terms of theta, but all the way back in terms of x. So let's see, this is 1 over 49 times 13, and it's probably fine to leave it like that. U was really tangent theta, so I've got tangent theta to the 13th power plus c. Now in order to figure out what tangent theta is, we should go back to our original substitution. The original substitution we made up here was x equals 7 sine theta. Or another way I could write that is sine theta is x over 7. And the reason I might want to write it like that is I can draw this little triangle. I can imagine a right triangle with some theta somewhere in there. Now we know that sine theta is opposite over hypotenuse, so this would be the opposite and this would be the hypotenuse. X over 7, opposite over hypotenuse, x over 7. And we can use the Pythagorean theorem to figure out what this other side should be. Well, this side squared plus this side squared should equal this side squared. Or this side squared is this side squared minus this side squared. So what we end up getting is the square root of 49 over x squared. And we're kind of encouraged because that square root of 49 minus x squared, that was in my original problem. So I'm not shocked to see that come up in my answer. But what am I asked to find here? I need to figure out what tangent theta is. Okay, so let's figure out, if this is my triangle, tangent theta should then be, well, opposite over adjacent. X over the square root of 49 minus x squared. So that's exactly what I'm going to put in right here. So my answer is 1 over 49 times 13, x over the square root of 49 minus x squared to the 13th power. That's what I get if I replace, sorry, I ran out of space, if I replace the tangent theta right here with x over the square root of 49 minus x squared. This is a fine answer. You could simplify it a little bit by making it x to the 13th or 49 minus x squared to the 13th over 2, but this is probably a fine way to write that answer.